In this video, we are going to talk about the root test. So here, the root test is very similar to the ratio test that we just finished speaking about. So the only thing that's different about the ratio test is that the root test has a nth root attached to it. So if the limit as n goes to infinity of the nth root of the absolute value of the a sub n's, if this equals to the limit that's less than 1, then it's going to be absolutely convergent. Okay, so same thing with the other ones. If it's greater than 1, it's going to be divergent. And if it equals 1, the test is inconclusive. So it's basically the same thing as the ratio test. But notice that in the ratio test, if we take a look at it again, um, when we did the ratio test, oh, I don't know what happened to it. Where's the ratio test? Okay, when we did the ratio test, we needed to figure out what this an plus 1 was. And in this case, we don't really care about that. All we just care about is getting our a sub n. And once we have our a sub n, apply an absolute value and take the nth root of it. Okay, so this is going to be really useful whenever we have like powers to the power of n. It's going to be really, really useful to do those. Not only that, but one of the things that to kind of take into consideration is that the limit as n goes to infinity of n 1 over n is equal to 1. So sometimes you might find this useful. Take it as a given. If you want to prove it to yourself, you can just remember you can use L'Hopital's rule and just write this as e to the ln of n to the 1 over 1 and prove it to yourself that this is actually going to go to 1. So you can use L'Hopital's rule, bringing this over and figuring this out. But for right now, you can just take this as a given so that it will save you a little bit of time. So this is something that you might want to consider memorizing. So let's do a couple of examples using the root test so that we can get familiarized with it and when to use it. So determine if the series is convergent or divergent. Okay, so let's say you had the sum from n goes from 1 to infinity of n to the power of n divided by 3, 1 plus 2 to the n, or 2n. Okay, so one of the things that we want to use is that the reason why I would consider using the root test here is because notice that you have a power of n. You have a variable raised to another variable. So, and if I were to apply an nth root, that would cancel out that n. So what I'm going to use is I'm going to use the root test. Okay, so using the root test. Okay, what I need to figure out is the limit as n goes to infinity of the nth root of the absolute value of a sub n. Okay, so I'm going to take the limit as n goes to infinity of the nth root of the absolute value of a sub n, which is going to be this guy. So n to the power of n divided by 3, 1 plus 2 to n, and then n the absolute value. Okay, now I can rewrite the nth root the following way. Limit as n goes to infinity of the absolute value of n to the n over 3, 1 plus 2n to the power of 1 over n. Okay, now with some of the properties of roots, I can actually distribute this inside of the absolute value. So what I'm going to get is the limit as n goes to infinity of n to the n over 3, 1 plus 2 to the n. And now what I'm going to do is I'm going to distribute this 1 over n into the absolute value, into their powers. So here I'm going to have a 1 over n. And for this guy, I'm also going to have a 1 over n. Okay, so this is just properties of exponents. So we have the limit as n goes to infinity of, the n's are going to cancel out, so I'm just left with 1n. Okay, on the bottom, if I distribute this 1 over n, you're going to have 3, 1 over n, plus the n's are going to cancel out, and I'm left with 2. Okay, so doing so eliminated this nth power. So now I can just have limit as n goes to infinity. Okay, now I don't really need the absolute values because all of these are going to be positive. So we're going to have n over 3 to the 1 over n, and I can break this up times 3 squared. So what I'm going to be left with is the limit as n goes to infinity of n over 3, 1 over n times 9. Okay, now I'm going to go ahead and put in infinity. So this guy right here, this guy's going to go to infinity. Because you just plug in infinity, you're going to get infinity. This thing is going to go to 0. Okay, so what you're basically going to have is infinity over 3 to the 0 power times 9. 3 to the 0 power is just going to give me 1. So 1 times 9 is going to give me a 9. Infinity divided by 9 is just going to give me infinity, which is greater than 1. And when it's greater than 1, it's going to diverge. So by root test, the sum from n goes to, 1 to infinity of n to the power of n, 3, 1 plus 2n, diverges. Okay. So the main thing about doing this is that the root test is just going to eliminate any power that you have up on the top. Okay. So it actually simplifies things a lot better. Okay. So now let's do another problem. So let's say we wanted to determine whether the sum from n goes from 3 to infinity of negative 12 to the nth power over n converges or diverges. Okay. So again, this looks a lot like an alternating series test, and you can actually use the alternating series test because you have a negative in there. You can actually break up the negative 1 and just leave the 12. But what we're going to do, let's go ahead and use the ratio test to get rid of that n. So I'm sorry, not the ratio test, the root test. So we're going to use the root test. So we're going to have the limit as n goes to infinity of the nth root of absolute value of a sub n. So you're going to have the limit as n goes to infinity of the nth root of negative 12 to the nth power divided by n. Okay, so you can absolute value. So now you can write the nth root as the power to 1 over n. Then you're going to have this negative 12 to the nth power over n. So this is going to give me the limit as n goes to infinity. So when I plug this 1 over n into this guy, these n's are going to cancel out. So you're just going to be left with a negative 12. And on the bottom, you're going to be left with n 1 over n. Okay. So now taking the absolute value into account, limit as n goes to infinity, top part's just going to give me a positive 12, and n over 1 over n. Okay. Now all we're going to do is take the limit. Okay, so the limit as n goes to infinity. So we just said that this top part is just going to be 12. What is this bottom part going to be? So if you have n to the power of 1 over n, what did we just say that to be? Is going to be equal to 1. Okay, so that part is going to be equal to 1. So this guy is just 1, which equals 12. This thing is greater than 1. So by root test, the sum from n goes from 3 to infinity of, negative 12 to the nth over n diverges.